So what we're working on today is we're still working with our radicals, only this time you are solving radical equations. So you got your equal sign in there. So our first scenario we're going to have is when you simply have one radical on one side of your equal sign. So you got that radical already by itself. So what you want to do is you want to raise it to whatever the index is. So for example, this has an index of 2. Remember, if there's no number written there, that means it's an index of 2. So that means we're going to go ahead and we're going to square both sides of that equal sign. So by squaring both sides, what happens is the radical gets canceled out. And then on the other side, 8 squared would give us a 64. And then we just continue our steps to solve for x. So I'm going to subtract my 4. So I get negative x equals 60. And then what do we divide by? Divide by negative 1. So we get x equals negative 60. Now the important thing that you always have to do, a lot of times with your other kinds of equations, you skip your check and you just move on to the next one. You have to check your radicals because there's almost always one of your values that you're going to reject. So you have to make sure you do your check. So we're going to plug in our negative 60. So then here, 4 plus the negative 6, or minus the negative 60 makes it 4 plus 60, so we get 64. Take the square root of it, and we get 8 equals 8. So this one does check out. But a lot of times when you get 2 answers, one of your answers is always going to get rejected. So you got to make sure you always do your check for your radicals. So for our next one, number 2, we have an index of 3. So what do you think we're going to raise both sides to? Yep, to the third power. We're going to cube both sides. So I get x minus 1 equals 27, because 3 cubed is 27. And then we just add our 1. And I get x equals 28. So again, let's just do our check, make sure this still works. So over here for my check, plugging in at 28 minus 1. We're going to see if that gives us a 3. So that gives me the cube root of 27, which is in fact 3. So that works out nicely as well. So then our next type, the radical is not on its own yet. So what we have to do first is we have to first isolate the radical. You have to make it so that it is on its own. So here we have the square root of x plus 3 equals 7. So first thing I have to do is subtract that 3 over. So then I get the square root of x equals 4. And now that that radical is isolated, we can do like what we did on the last ones. So this is just a square root, so I'm going to square both sides. So we get x equals 16 as our answer. So let's do our check. So we're going to plug our 16 in for our x in our check. Square root of 16 is a 4. So that works out. 7 does in fact equal 7. So our next one, we have the square root of x plus x equals 6. So what do we have to move first? The x. We got to isolate the radical. So I get x equals 6 minus x. So then we're going to square both sides. But I'm going to put the right side in parentheses because I've got to square that whole thing, 6 minus x. So over there on the left, my square root of x squared just gives me x. Over here on the right, I'm going to write it out twice, and then we need to multiply. Because it was x, or 6 minus x squared. So that's going to be 6 minus x times 6 minus x, and then we just need to distribute. So 6 times 6 gives me 36. 6 times negative x gives me negative 6x. So negative x times 6 gives me negative 6x again. And then I get a positive x squared. So I've got to combine my two like terms, and I'm going to bring this negative x over. Well, I'm sorry. I'm going to subtract my x over, so it becomes a negative x over there. So I have 36 minus 13x, because negative 6 is negative 12. Then minus my one other one is negative 13x. Plus my x squared. So again, we have an x squared there, so we're going to have to factor. So we got to think to ourselves, what multiplies to give us 36, but will give us a 13 in the middle? Very good, 9 and 4. Our signs are the same. So I get 9 minus x times 4 minus x. Yep. So what do we do next? Very good. Set them equal to 0, just like we were doing in our last day of notes. Yep. So let's do our check. So if I check up here, plug in my 9 first. So the square root of 9 plus 9. We're going to see if that gives us a 6. So the square root of 9 is 3. Plus the 9 that was there gives me a 12. Does 12 equal 6? No. So we got to reject the x equals 9. So then if we check our 4, so the square root of 4 plus 4, we're going to see if that one gives us a 6. So I get 2 plus 4, which in fact does equal 6. So we get 6 equals 6 for that one. So the only one we keep from that answer is x equals 4. All right, number 3. Is our radical isolated? No. What do we got to do? Divide by 2. For right now, I'm going to leave it as x minus 2 over 2. How else could we write it? Which actually, as I think going forward, I think that's what we should probably do. Oops. X minus 2 minus 1, because I divide the x by the 2, and then 2 divided by 2 gives us 1. It's going to make things a little easier. Yep, so now we square both sides. So I get x plus 1 equals x minus 2 minus 1 times x over 2 minus 1. So let's have you take a minute, go ahead and multiply out your right side over here. Do your distributive property. So I'm going to go ahead and I'm going to combine my like terms here. Yeah, so these are both 1, so that would become 2x over 2 plus 1. Yeah, I'm going to bring that over too. No, we wouldn't cancel it out. So what would happen with my 2's here? Those would turn into a 1, because 2 over 2 would be 1, so I have just a negative 1x there. But looking forward, do you think we're going to be able to factor with an x squared over 4? No. So what I'm going to do is I'm going to multiply everything times the 4 to get rid of that fraction so that our factoring life is going to be a lot easier. So this is going to give me a 4x plus 4 over there on the left. On the right, we would get x squared minus 4x plus 4. So now I'm going to subtract my 4x over and subtract my 4. So that side gives me a 0. Over here I would get an x squared minus 8x, and then our 4's also cancel on that side. So what kind of factoring do we have here? GCF. What is our GCF? X. We'll move up over here. So I get x, and then x minus 8. So we get x equals 0, and x equals a positive 8. So then we just have to check to make sure they both work. I'll do my check right down here. So plugging in my 0, zero plus 1 gives me the square root of 1, which the square root of 1 is what? 1. So times my 2 would just give me a 2 there. And then 0 minus 2 would give me a negative 2. Does 2 equal negative 2? No. So that one gets rejected. So then let's check our 8. So then 8 plus 1 gives me a 9 under the radical. The square root of 9 is a what? 3. So then 2 times 3 gives me 6. So we get 6 equals 6. So our answer for that one would be 8. Alright, let's try our fourth one there. So what do we want to do first? Subtract the 1. So I get the cube root of x minus 2 equals 3. And it's nice for the cube root that we don't have a binomial over there that we have to multiply out 3 times. We just have a single number 3. So I get x minus 2 equals a 27. So then add my 2 over. And we would get x equals 29. So then, of course, let's check. Make sure 29 actually works, and then we don't have to reject it. So we're going to see if the cube root of 29 minus 2 plus a 1 is going to give us a 4. So 29 minus 2 gives us a 27. Cube root of 27 is 3. So 3 plus 1 does in fact give us a 4. So that works. So we get to keep our 29. Alright, then our last two on the back, these ones are a little bit longer. This time we have 2 radicals. So when you have 2 radicals, what you want to do is you want to move one to the other side of the equal sign and have the other one on the other side. So you got 2 radicals on both sides. So for number 1, I'm going to add my 2 radical x plus 8. So I get 3 radical x minus 2 equals 2 radical x plus 8. So now we only have 1 radical on each side. So we're going to do the same thing we would on the front. I'm going to square my left side, square my right side. I used parentheses this time because you got to remember to square those numbers out in front also. So this 3 squared would give us a 9. And then it would be times the stuff underneath the radical. So the 9 times the x minus 2 is going to equal a 4 times the x plus 8. And I just got a normal equation for you guys to go ahead and solve. So we got to distribute our 9, distribute our 4. So 9x minus 18 equals 4x plus 32. Subtract our 4x. I'm going to add my 18. So I end up with 5x equals 50. So divide by 5 when we get x equals 10. So then, of course, we have to check it. So we got 3. We want to check it back in the original. Alright, so I'll plug my 10 in for my x's. So this gives me 3 square root of 8 minus 2 square root of 18. So we're going to have to simplify these radicals so we can subtract them. What's our perfect square that goes into 8? 4. So then the 4 comes out as a 2, then times the 3 that was already there. We end up with 6 radical 2. So then what's our perfect square that goes into 18? 9 and 2. 9 comes out as a 3. When times the 2 that was already there would give us a 6 radical 2. So then 6 minus 6 gives us 0. So it works. So 10 is our answer for that one. So let's look at number 2. So again, we want to separate the radicals. So what I'm going to do is I'm going to subtract my square root of x plus 5. So I get the square root of x minus 3 equals 4 minus the square root of x plus 5. Yep, and then we're going to square both sides. What's going to end up happening is we have to do the square over on the right side with a radical. It makes it a little trickier, but we can still do it. So we get x minus 3 over there on the left. And as I was saying, we would have to write this out twice. So 4 minus the square root of x plus 5 times 4 minus the square root of x minus 5, or x plus 5. Now we'll start distributing. 4 times 4 gives us 16. And then minus 4 radical x plus 5 when I multiply those two. And then we distribute the other radical, so that gives me a negative 4 radical 5 x plus 5. And then when I multiply the two radicals together, they kind of cancel out the radical, because it's the same as saying the square root of x plus 5 squared. It cancels each other out, so you're left with just the x plus 5. And since they were both negative, it turns out to be a positive. So now combining our like terms, we would get x minus 3 equals 16. Well, no, not 16. Because we got to do the 16 plus the 5. Yeah, so 16 plus the 5 would give us 21 plus the x minus the 8 radical x plus 5, because the negative 4 plus the negative 4 would give us the negative 8. So what we want to do now is we're going to have to square again. We have to isolate that radical now. So I'll subtract my 21 and subtract my x. So the x's actually end up canceling on both sides. Negative 3 minus 21 is negative 24. Bless you. So I get negative 24 equals the negative 8 radical x plus 5. What should we do with that negative 8? Divide. So I get 3 equals radical x plus 5. So I'll square both sides. So we get 9 equals x plus 5. Subtract our 5. And we get 4 equals x. That was a long problem. So what's the last thing we have to do? Check it. So let's see here. So 4 minus 3 plus 4 plus 5. We're going to see if that gives us, thank you, 4. So 4 minus 3 gives us a 1. Square root of 1 is 1. For the other one, 4 plus 5 gives us a 9. Square root of 9 is a 3. So then 1 plus 3 does in fact give us 4. So the answer for that one is x equals 4.